Hey, today we're going to talk about Kubernetes and AI, specifically how we can prepare our Kubernetes clusters to be able to handle AI workloads. If we want to deploy an LLM or some other AI training job into our Kubernetes cluster, this is how we're going to do it. We're going to cover that today. This is the third video in a series that I'm doing on Kubernetes and AI, right? In the first two, we covered how do we set up pass-through GPU in a host server so that our VMs can claim that GPU. Then we deployed Kubernetes, specifically K3s, with a node that has that GPU device attached. Today, we're going to talk about advertising GPU availability. And what's cool, you don't actually have to have seen the first two videos, because at the end of the second video, I mentioned that from here on out, it's just Kubernetes. So in case you have no interest in ever setting up a lab server or your own GPU device, right, with PCIe connection and everything like that, you just want to use cloud environments, you can just pick up from this video. From here on out, everything that we do can be done in a public cloud. And I'm going to prove it by using EKS for the first part of this video before we come back to my lab server to save some money, because I'm paying for this and no one is sponsoring these videos, just FYI. Okay, so if you haven't seen the first two videos, which again is fine, this all started with three questions that I had that I didn't really have the answers to. So in the first two videos, we already answered that last question. How is the underlying node managing that GPU device? Nice. Today, we're going to talk about how does Kubernetes know where the GPU is. We're going to answer this question, and in order to do that, I first want to take a look at the first question. How does a pod request the GPU device? Right? Let's look at this manifest that I've got over here. Come on, there it is. This is a pod manifest. It's going to deploy out the Nvidia CUDA image that Nvidia provides running on a base Ubuntu 2020-04. Cool, and it's going to run this Nvidia SMI command. Now, I ran that in the previous videos, and that helps us test connectivity back to the GPU, right? It's an Nvidia CLI, and it stands for System Management Interface. It's how we know what is going on the GPU, right? Is anything using it? How much memory is left? All those things. So this is going to run the CUDA image. CUDA, if you're not familiar, stands for Compute Unified Device Architecture. And NVIDIA, in their wisdom, has prepared this nice page that you can look into to find out all about the CUDA platform and all the CUDA libraries that they provide. Very nice. So we come back to cursor. This is going to request, right, a limit and resource request right here of NVIDIA GPU 1. Why 1? Well, in typical GPU allocation, we allocate the entire device. There are ways to split a GPU. That's beyond the scope of this video, but if it's something you want to see, let me know in the comments. We can cover it when we get further into this series. Now, this is using an OpenTofu repo that Claude and I put together to stand up an EKS cluster in AWS, right? And if I look in main.tf, you can see it's not doing too many things. It uses some open source AWS Terraform modules, right, to stand up my VPC. And then down here to stand up my EKS cluster. It's got the core add-ons, and then it's looping over node groups defined in my variables. So let's look at my variables. And down here are my two node groups. I have a standard node group, and then I have this one down here, right? This is my GPU node group. And it's using G40N extra large, and that's going to deploy out a node with the NVIDIA T4. Cool. So this is how I'm actually standing up my EKS cluster with a GPU device attached to one of the nodes. Now I could scale this, right? I'm only saying desired size is 1 because again, this is my money, but I could scale this to have more than 1. Well, for now, this will do. So this is what's currently running in my AWS account. And if I come into Z shell, we could see, all right, kubectl config view minify grep server, I'll do that. And there it is, right? I'm running against an EKS cluster. Perfect. So now let's apply. Let's deploy out that pod that we were just looking at. And it's up. Cool. Now you might be thinking, all right, it took the pod. That means it's allocating. No, it's not, right? Even with this limit of NVIDIA GPU 1, even though it took it, even though the validator didn't throw any errors, it's not actually doing anything. And I can prove it, right? Let's delete this. Let me kubectl delete pod CUDA smoke, and I will apply a limit that definitely doesn't mean anything to anyone, right? colinj.com/codesalot1. So if I apply this, right, if I apply this same thing, it'll take that too, right? And in both cases, if I kubectl describe the CUDA smoke pod, we're going to get 0 of 3 nodes are available, insufficient codesalot and insufficient GPU. In both cases, Kubernetes doesn't know how to allocate either of those resources because it doesn't know what either of those resources are. So what's cool about Kubernetes is that if you pass in a fully qualified domain name, whether that's colinj.com or nvidia.com /a resource, it will take it. Why? Well, according to the Kubernetes docs, right, you can set up extended resources using things like device plugins. Device plugins are actually an extension that Kubernetes provides an API for, and you can use it to add new devices in the underlying node, things like GPUs, NICs, whatever. So this fully qualified domain name approach allows you to get past the validator by passing in custom domain resources, things like, come back, nvidia.com/GPU or something that doesn't even exist at all. Either way, the scheduler won't know how to schedule this pod. It won't know where to put this pod because you're asking for a resource that the Kubernetes cluster doesn't recognize. Now, if you're wondering, well, is that for all things? No. If I come back to the top and I delete this pod, and then we try to apply something absolutely ridiculous, like just colinj codesalot1, notice that's not a fully qualified domain name. I try to apply this. Yep. And it's going to blow up. It's going to error out and say, that's not a thing. I know for a fact that's not a thing. Cool. So I'll recomment these out because we're not going to use that anymore. But this is how we're going to request GPU once the Kubernetes cluster knows how to allocate it. So that's the part that we're missing, and that's what we're going to cover today, right? Cool. So we already covered how do you request GPU? You do it like this. And there are, again, ways to divide the GPU so you're not requesting the whole thing. Topic for a different day. So let's come back to the PowerPoint. The way that we're going to handle this is by deploying out the GPU operator Helm chart that's provided by Nvidia, and that installs a bunch of things into our nodes, right? So first we have the GPU operator, and that's going to adhere to the operator framework. So it's going to react to different resources that you deploy out, and it's going to handle them appropriately. Very cool. Then we have feature discovery. Now this is important because different GPU devices, different Nvidia GPU devices have different features. So this is actually going to run against all of your GPUs that it finds in your cluster, and it's going to detect what features they support. We'll talk about that in a second. Then there's the GPU driver, and it deploys this out as a container onto your different nodes. And what that does, if you saw the previous videos, the GPU driver allows the VM, the underlying node, to claim ownership of that GPU device that it's attached to. So this is going back to that question. How does the underlying node manage that GPU device? GPU driver. And this is why you didn't have to watch the first 2 videos if you're not interested in those low-level details, because this installs it for you, right? This handles it so that you don't have to get into the nitty-gritty of actually managing it line by line in the command line or in your user data file. Then there's the container toolkit. Again, previous video we covered this, so I won't go into too much detail, but container toolkit installs all of the NVIDIA libraries into the container runtime on that node. Again, you don't have to watch the first 2 videos. This handles all that for you. Then there's the device plugin. This is where we actually extend Kubernetes, right? This is where we say, here's how you handle GPU requests, is in that device plugin. Then we have DCGM, Data Center GPU Manager, that handles observability metrics for us if we want to get into that, and that's a topic for another video. And then MIG Manager, Multi-Instance GPU. Now, MIG is a feature that's not available on my T4 in AWS, nor is it available on my RTX 5060 sitting in my closet back there. And we'll know that because of this, the GPU feature discovery. Now, when we install all this, a bunch of stuff is going to happen. First, we have our Kubernetes cluster. Great. But then those pods, those daemon sets that are part of that Helm chart, they're going to run discovery against all of our nodes and say, this is where the GPU is. It's going to search against each node and it's going to see, is there GPU attached? If there is, it'll label it. It'll slap labels on the nodes that have the GPU and say, this is where we can schedule GPU workloads. Cool. Let's see that work. So we come back over here, right? And I'm going to come back up to my shell. Now, before we get into actually deploying the Helm chart, one thing I want to look at is this GPU node that I've got set up. So I'm going to paste in this command, describe node that has the label, nvidia.com/GPU equals true. That's the one that I set up, right? When I describe it, and we look at the allocatable resources here, right? This looks pretty standard. All of these allocatable resources are what you would expect to see if you describe any node in your Kubernetes cluster. The fact that this has GPU attached to it doesn't make it special yet because there's nothing that we've done in our Kubernetes cluster to make it special. Okay? Kubernetes doesn't know what to do with this. So the API is just reflecting these standard allocatable resources. Well, let's change that. So I'll clear this out. Clear this out. Yep. And I will paste this command in, helm upgrade install GPU operator in the namespace GPU operator. We're going to create that namespace and it's going to use the Nvidia GPU operator chart and we'll hit enter. And then, all right, cool. So it's installed. That was awesome. We'll kubectl get pods in all namespaces and we'll start to see a lot of different Nvidia pods right here. They're all running, they're initializing, right? These are all the different pods that were deployed out. So I'll clear this again. I will clear this again. And then we'll run that same describe command, right? And we're going to start to see some different stuff. All right, very cool. Here, look at this, look at this, look at this. If I come up to allocatable, how many GPUs are available? 1. So we now have our GPU available. Kubernetes now knows what to do, right? Because I ran the kubectl command, so this is definitely working with the Kubernetes API, and the Kubernetes API is telling me this is where the allocatable GPU is. That's awesome. And now if we come up to labels, we're going to see a lot of labels. Look at all these labels, right? We have all of these NVIDIA deploy labels. We have all of these different Kubernetes feature labels. This was all done by the feature discovery pod. All right, cool. So we'll clear this and now we'll actually apply that pod again, right? We have an allocatable GPU. So I'll kubectl apply the test GPU pod. Cool, it's deployed. And now I'll kubectl describe pod, kuda smoke. All right, and it was successfully assigned. That's great. So Kubernetes now knows how to schedule it. Let's get the logs. Kubectl logs. Pod, kuda smoke. There we go. Cool, it ran NVIDIA SMI. And look, where is it? It's around here somewhere, the Tesla T4. So it's a pod, right? This is a pod. We got the logs from my pod and it's working against that GPU and it's interacting with it to give me all the stats using NVIDIA SMI. That's awesome. So this is how we do this, right? This is how we deploy out a pod that's going to request GPU. Now let's come back to over here and real quick, let's review everything that we just installed because we just installed a lot, right? You don't necessarily need all of this. In fact, the 3 things that actually make your Kubernetes cluster work with AI pods are these right here, the GPU driver, the container toolkit, and the device plugin. Now, there are other features, right? There are a lot of other features that you may want to use, but for a lab server or a small cluster that you want to manage yourself, this is all you actually need. And if you want to keep this slim, you can do that. You can just deploy out the device plugin after you install the GPU driver and container toolkit. Well, in the lab server, my Intel NUC, I've got in a closet back in the corner of my office over here, I've already installed the GPU driver, the container toolkit, and now the only thing I'm missing is this device plugin. So what would it look like if we just deployed that? All right, so now we're back in my OpenTofu repo that I use to stand up a K3s cluster in my Intel NUC that's sitting in my closet over there, right? That's got the 5060 Ti GPU attached. So I'm running against this kubeconfig, right? Look at that sweet local address right there. So I'm using that. Let me export, yep, kubeconfig equals that file right there. Now, if I wanted to, I could install the Nvidia GPU operator, right? I've got a values file. In the previous two videos, I installed the driver, I installed the container toolkit. So I have to modify the values a little bit, but I can still deploy out the GPU operator and it'll work. In this case, I just want to demo how I would install the device plugin entirely on its own. So before I do that, we'll look at my GPU worker 0 and we'll grep on its capacity. And sure enough, there's no GPU attached. Again, I have not modified the Kubernetes cluster so that it knows how to allocate pods requesting GPU. So let's do that. Let's kubectl apply Nvidia Device Plugin YAML. That's this file right here. And it's everything I need to install the K8's device plugin that Nvidia provides. Okay, so I'll hit enter here. And we gotta wait a few seconds, right, for the image to get pulled, for it to start setting up the pods. So I'll kubectl get pods in all namespaces. Cool, so container creating, and it's installing, it's a daemon set, so it's installing a pod on each of the nodes. Now, if I wanted to, down here, I could have just limited the node selection to a label that I applied to the node that's got the GPU attached. But it's kind of more fun to see it just allocate, or to see it just recognize the GPU on the node that has it and say that all the other nodes don't. So come back in here, we'll clear this, and let's see, and let's get the status of the pods, and they're running. That means I should be able to see, if I describe this node again, my GPU worker in my K3's cluster, describe this node, and sure enough, there it is, NVIDIA GPU capacity 1. So I can apply the CUDA smoke test GPU pod, right? That's the same CUDA smoke pod that I deployed in EKS. I can apply this again. Very cool. It's been created. And now if I kubectl logs, it was logs, CUDA smoke, kubectl logs, CUDA smoke F. Cool, there it is, 5060 Ti. That's my device. That's what's sitting in that closet back there. Now we have pods actually touching the GPU. Whether we're talking about my K3's cluster running in my closet back there, or we're talking about EKS or any other public cloud provider, we have ways. We now know whether you're using the operator or the device plugin on its own. We have ways to tell Kubernetes, here's how you work with GPU requests. Here's how you allocate GPU pods, or pods that need GPU, right? So that they can run AI workloads. That's awesome. This is awesome. So in the next video, we'll actually do that. We'll look at how we can deploy. There's a few different deployment methods. We'll look at how we can deploy LLMs into our Kubernetes clusters. I will provide links to both of these repos, the EKS OpenTofu and the K3's OpenTofu, in the description. If you have any questions, if there's other stuff you'd like to see, please drop a comment. If you like this video, please consider dropping a like. And if you want to see more videos like it, including the next one in this series, please consider subscribing. Thanks for watching.